Hello developers. Welcome back to AnbuZ HobbieZ. Today, we're delving into the observer design pattern in Java. If you've ever needed a way for an object to notify its dependents of any state changes without coupling them tightly, you're in the right place. Stick around as we explore the basics, showcase a real-world problem this pattern solves, break down the UML diagram, provide a hands-on code example, discuss its advantages, highlight common pitfalls, and wrap up with a solid conclusion. Imagine you have an object, and you want multiple other objects to be notified whenever its state changes. You don't want these objects tightly coupled, and you want to achieve this without introducing unnecessary complexities. This is where the observer design pattern comes into play, providing a clean and efficient way to implement such a system. The observer pattern consists of two main components, the subject and the observer. The subject is the object being observed, and the observer is the object that wants to be notified of any state changes. When the state of the subject changes, all its registered observers are notified automatically. This decouples the subject from its observers, promoting a flexible and maintainable design. Let's dive into some code. I have a simple Java project set up, and we'll implement the observer design pattern to demonstrate how objects can be notified of state changes. I'll guide you through each step, and by the end, you'll have a practical understanding of how to use the observer pattern in your own projects. In this example, we'll create a basic news agency system where multiple news channels act as observers to receive breaking news updates from the news agency. News agency is the concrete subject that maintains a list of observers, news channels, and notifies them of any updates. News channel is the concrete observer that receives news updates from the news agency. When the news agency sets the latest news, it notifies all registered observers, and they, in turn, update their channels with the breaking news. Now, let's talk about the advantages of using the observer pattern. 1. Loose coupling. The observer pattern promotes loose coupling between the subject and its observers, allowing for better maintainability and flexibility. 2. Ease of extension. You can easily add or remove observers without modifying the subject, making the system more scalable. 3. Consistent state. Observers are notified automatically when the state of the subject changes, ensuring consistency across the system. However, it's important to be aware of potential pitfalls. 1. Unexpected updates. Observers might receive updates that they are not interested in, leading to unnecessary computations. 2. Ordering of notifications. The order in which observers are notified might be crucial, and the pattern does not inherently guarantee a specific order. And there you have it, a deep dive into the observer design pattern in Java. We've covered the basics, walked through a real-world example, discussed its advantages, and highlighted common pitfalls. Whether you're building UI components, handling event-driven systems, or implementing any scenario where objects need to stay in sync, the observer pattern is a valuable tool. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more design pattern insights and Java tutorials. Happy coding, and I'll catch you in the next one.